Alright, in this video we're just going to talk about the examples. Example 1, two obtuse vertical angles. Obtuse means they got to be more than 90. Excuse me. They got to be more than 90, so we're basically talking about VZX. There's no other ones here, but if I added 50 and 65, I should also get 115, which is YZW. So VZX and YZW are what we consider vertical angles and they're obtuse. Those are the two I would write there. So I'll just type it in. Sorry, I don't have the symbol, but make sure you don't forget to put your symbol there. So YZW and VZX. Don't forget I'm missing the angle symbol. So make sure you put that there. Alright, and that's for obtuse vertical. Now, another pair of vertical angles that are acute, we can name VZY and XZW. That's what we consider vertical acute. Don't forget, vertical angles are, in a sense, opposite of each other, and they share the same vertex. And if you want to be double sure, per the definition, make sure that the rays are opposite. In this case, these two angles here that I'm pointing at are vertical. Why? Because ZX is opposite of ZY and ZW is opposite of ZV. So those are vertical. And if you notice too, these two angles are 115 each. Don't forget YZW is actually 115 because we added the two angles inside of it. And also too, VZY and XZW are also congruent. We'll learn about that later. Alright, two acute adjacent angles. Remember, adjacent means they got to share a vertex and a side. So technically we got options. We can name a couple actually. These two angles are acute, and per the definition they're also adjacent. These two angles are acute, and per the definition they're also adjacent. These two angles are also acute, and per definition they're adjacent. Remember, adjacent means they have to share a vertex and a side. They basically overlap each other, they're next to each other. So I can just name several options here. Again, I don't have the angle symbol, so just bear with me on that. But a couple pairs is VZY and YZT. That's one. Another one is what? We said YZT and TZW. And if you want to, the last pair that you can name is TZW and WZX. Again, what's adjacent mean? That they share a vertex and they share a side. And like I said again, if they share the side, which is the ray, that means that they share the vertex as well. Alright, and here remember you needed two, so I gave you guys three. This is also in the book, but I'm just explaining it to you. Alright, next example. Angle measure. Find the measure of two complementary angles if the difference in the measure of the two angles is 12 degrees. Complementary means again that they add up to 90, and their difference is basically 12. So we can just simply write first. We know there's two different angles. One of them is X and Y. But since they're complementary to each other, you can basically say one is 90 less than the other. So what we can do is real simple. Keep it simple. I'll just put 90 minus X. And then minus X should equal to 12. Now the theory behind that is this. We know it's two different angles. One is X, one is Y. But instead of naming one Y, I'm just going to say that it has to be 90 degrees minus the same angle, which is X. So you can just work this out. Now when you work this out, you're basically combining like terms. Don't forget here, I can put a 1 in front and do distributive property. When I do that, all that basically happens there is that you do 90 times 1 and 90 times negative 1x, which is just basically 90 minus x. Let me just put it back in smaller caps. And then you do minus x again, and that equals to 12 and then from there you combine like terms. Again, in front of the x's there's a 1, so what you're really doing there is -1, which is going in the same direction of the number line, which is -2. And then you just do your algebra from there, which is basically inverse operations. You know you can't subtract 2x from 90, so you got to combine the 90 with the 12. And the way you do that, you just subtract 90 from both sides. Again, it's a little messy, I apologize, I'm just showing you. Alright, those 90s cancel, so all you have left is, I'll put it here, all you're going to have left is the negative 2x equals to, I believe it's, what is it, 78? Negative 78. I think it is. Calculator, just in case. What is it? 12 minus 90. It is negative 78, so that's what it is. And then from there, you know that the negative 2 and the x are multiplying. So what you have to do is divide. So you just divide both sides by 2. And then you're just basically going to get x is equal to whatever 2 times negative 78 is. Calculator again. So we just divide that by 2 and we get negative 39. It shouldn't be negative though, because these two negatives become a positive, so it's just 39. Now if we wanted to, we can find out what the angle measures are. One of them has to be 39 degrees. So we can just say x equals 39 degrees. Don't forget there should be a degree symbol on top. I can't do it here on the computer, but you on paper, make sure you put the degree symbol. And then y, since y is a complement of x, we said that that was equal to basically 90 minus x. So then, hence, we'll just put y is equal to 90 minus 39, and then we'll get our answer there of what y is. Calculator again. Just trying to do this fast, so that's why I'm using the calculator. Alright, get out of the way. Oh, what was it? 51, okay. Nope, don't want that. We're here. There we go, 51. And again, don't forget, you need to put a little degree symbol on top. So all they wanted to know was, actually they did want the two measures. One of them was 39, one was 51. If you want to test it, you basically should read that 51 plus 39 should give me 90, and it does. So it's good. Alright, next example. Remember, the only part here that might be a little iffy is that, remember, if they're complementary, that means that they have to add up to 90. So if you work backwards, the difference must be 90. And the only reason I put minus here was because they said that if the difference in the measures of the two angles is 12. Remember, in math terms means equal, difference in math terms means minus. Alright, here. Let's make this a little bigger. Okay. Here, real simple. The only new term here, this is just algebra here. The variables and the expressions, but the geometry part is simple. X and Y, find X and Y so that BE, ray BE, and ray AD are perpendicular. So if they say perpendicular, they even put it here again. Well, this is what the book gives you. But if they say perpendicular, let's find BE. BE is this, which is, well, technically it should be a line, even though that looks like a ray. So let's just say line BE and line AD. So that's perpendicular. That means they make how many degrees? 90. And they make 90 all the way around, right? So that means all of this is 90 degrees, okay? All of it. Let's make it a little bit smaller. So all of this is 90. Ugly square, but that's okay. Alright, so all of it's 90. We can technically find X and Y separately. How do we do that? Don't forget, angles is the rotation inside. So let's work with the Y first. Alright, here, we can ignore the parentheses because it's just one term. So 12y minus 10 should equal to how many degrees? If this is perpendicular, that means all the perpendicular lines, when they intersect at 4 right angles. So this is going to be equal to 90. And the other equation, we've done it before, even though it was simple, it only had numbers, but in this case, one angle that represents 6x plus the other angle that represents 3x should also equal to what? 90 degrees. Because this rotation here is 90 degrees. Why? Because BE and AD are perpendicular. Now they made it a little bit easier. They should have just put this symbol here. That symbol you should already know. On the test, you probably just get the symbol. They're not going to spell it out for you. All right, so then here you just do the algebra. Okay. And here, first things first, we got to combine like terms. So we can combine the 10 and the 90 and the minus 10. So to combine that, we got to add 10 to both sides. Oops, work with me. Hold on. There we go. All right, and then from there, once you do that, the 10's cancel because minus 10 plus 10 is 0. So then what you have left is 12y is equal to 100. And then from there, you know you have to divide by 12. And when you divide by 12, I believe you get a decimal, which is fine. The decimal in there would be, let's see. Let's get this out. So it would be 100 divided by 12 is 8.3 repeating. 8.3 repeating, we'll leave it like that, even though I prefer to have a fraction. The fraction would definitely be, let me see, 8, and 8 times 12 is, I believe is 96. So it will be 8, 4 over 12, which reduces to 1 over 3. So even though this is what it is decimal-wise, the fraction will be actually 8 1/3. Moving on to this one, here we can combine the terms because they're on the same side. So 6 plus 3, x is 9x. Remember, there's no number in front of the variable. You can put 1. It's always 1. Same thing with the parentheses. And here, since 9 is multiplying x, you divide both sides by 9, and you're going to get x is equal to 10. And all they want us to find was x and y, so we're done. Again, 8.3 repeating is really 8 1/3. The reason I got that was 12 goes into 100 8 times. The remainder is 4. So it's really 8 and 4 over 12. 4 over 12 it actually simplifies to 1/3, which is where you get the 0.32233. Now again, on paper, you don't have to put this. You can just put 8.3 with a line on top. Make sure you put that because that's the exact answer. Okay, moving on to example 4. Determine whether each statement can be assumed from the figure below. All right, we can make a lot of assumptions here. Forget this. Let's just look at this. Okay, this little line says that segment LP is congruent to segment PQ right off the bat. If you want, you could write that down. LP is congruent to PQ. We can also say with this little red loop here, the angle LPM is congruent to OPQ. This is kind of like the same thing in the book in the beginning, but now they added markings. When you have markings, you can assume anything. Markings are your best friend. No markings, you can't assume. And also, this box means that this line, this angle, which is MPN, is perpendicular, not perpendicular, excuse me, it's a right angle, which means that ray PN and ray PM are perpendicular. All right, so adjacent, let's look at that. LPM. It might be adjacent because I see MP and PM. Let's look at the picture first, though. LPM and MPO. Yes, those are adjacent. That's fine because they're basically next to each other, right? Not one angle is not one inside of the other. So LPM is here. This is LPM. Let me use the arrow. LPM is this, and this is MPO. Let's try to do this. Let's see if this works. This is one of them. Yeah, that doesn't really work too well. I don't have a steady hand for that. But going back to the arrow, LPM is adjacent to MPO. Yes, that is true. They share a side and vertex, which is PM, ray PM. All right, here, complementary. Their complementary means I have to add up to 90. I don't really see that here. All I see is 190 degree, and that's it. And there's nothing inside of this, so there's no ray dividing MPN of the angle, so I don't see that happening. But let's see what they got. Angle OPQ. OPQ is this, and then LPM. LPM is this. They're not complementary because the reason I say that because we don't know how many degrees these angles are, you know. And since we don't know, we know they're congruent, but we don't know how many degrees there are. So here we got to say no. It's not safe to assume. Now they told me these two angles here were 45 each. Okay, go for it. Yes, but since they don't say that, no. Here, linear pair. If they're linear pair, that means they got to make a straight angle and they got to be adjacent. Just by looking at this, they got PO, so chances are they might be adjacent. Let's check. LPO. LPO, that's a big obtuse angle. It goes from here all the way to here. LPO. and then the other one has to be then, without even looking, to make the straight angle, which is LPQ, has to be OPQ. And that is correct. Yeah, they name it QOP, but OPQ and QOP, same thing. So yeah, this does make linear pair, because it's this angle here, which is LPO, and the other angle is OPQ. They make linear pair because not only they're adjacent, they share the side, which is PQ, the ray, and the vertex, which is P, but they also make a straight angle together. In other words, they make a a half rotation. All this is 180 degrees from here all the way to here. So these two angles is just one case. So LPO and OPQ is one case. Yes, that is true. We can make another case if you want. I'll type it in just so you can see what's going on. Again, I don't have the angle symbol, but make sure you put it. Remember, I'm typing. So we got angle LPM and, oops, I want lowercase. There we go. LPM is this one, right? So then we got a little rotation here. We got to go off from here all the way over here to make that straight angle. So that's going to be then MPQ. That's one other example. There we go. That's another example of a linear pair. Linear pair is safe to assume because the straight angle is always 180. That's never going to change. And I think that's it. Let me see. Yeah, that's it. This is just a guided practice. I'll have a separate video for this if you're interested. Alright. Thank you for watching.